Today we travel to Oxford University in England to meet Professor Jocelyn Bell Burnell, who has enjoyed a distinguished career in the field of astrophysics. She gained a PhD in radio astronomy from Cambridge University and was involved with the discovery of pulsars, which led to a new field of astrophysics being created. She's been awarded numerous prizes in science and has been a dean at Bath University. We started by asking her to describe astrophysics and what her work involves.
Astrophysics is the study of stars and galaxies, trying to understand why they shine, why they're the colour they are, why they're the shape they are. It's a high-tech subject, a high-tech branch of modern physics, if you like. And my work in particular involves going to a telescope, collecting some data for a few nights, and then coming back home and spending weeks and months in front of a computer and in a library looking at the data I've got and trying to make sense of it. I became interested in astronomy as a teenager through reading some library books and decided that's what I'd like to do if I could. I did science and maths A-levels, physics and maths, and then went on to university, did a physics degree, and after that a higher degree as well, a doctorate. I was attracted to astronomy because of the immensity, the sizes, the distances. It was very impressive, and it's also very, very beautiful, looking at a clear night sky with the dark sky and pinpoints of stars. It's gorgeous.
Professor Bell Burnell was involved in the discovery of pulsars, but what are they and how did that discovery come about?
The discovery of pulsars was accidental, like some of the best discoveries are. The analogy I use is, imagine you're at a viewpoint and you're making a video of a sunset, and a car comes along and parks in the foreground and it's got its hazard warning lights flashing. Spoils the video. It was a bit like that. I was meant to be studying quasars, which are some of the very distant things, and something in the foreground popped up and said, "Yoo-hoo!" And those were the pulsars. So accidentally tripped over them, so to speak. The pulsars were totally unexpected, and so they opened up a new branch of astrophysics when we realised what they were, because we hadn't had a chance to study things that dense before. It opened a whole new window on the galaxy. It's another way of putting it. Yeah. Pulsars are really bizarre objects, and I find quite hard to believe in as well. They're very massive. There's 1,000 million tons of stuff, all jammed into a ball about 10 miles across. If you took a tiny volume of a pulsar, that amount of pulsar material would weigh the same as the 6 billion people that inhabit Earth. They've got very strong gravity and quite a strong gradient of gravity as well. If you were to go and land on a pulsar, not to be recommended, but if you did, you'd find as you got close that your body was getting stretched out. The technical term is spaghettification. And then as you get close to the pulsar, the spaghetti breaks. So it would be fatal. But there's very, very interesting physics in those objects, lots of science, and huge fun to study them. Finding something that unexpected was of course very exciting, but it was also, particularly to begin with, very puzzling and quite worrying, because you think there's something wrong. You think the equipment's misbehaving. The cosmos doesn't give you signals like that, does it? So it must be something wrong with the equipment. And we spent about a month trying to find out what was wrong, and we're gradually forced to accept that it wasn't anything wrong with the equipment. It was actually a new kind of star, and I'd stumbled over the first few examples of it. Finding the second and third and fourth was much more fun than finding the first one, which really was a bit troublesome. Yeah, we built the radio telescope ourselves, about 6 of us, and I had responsibility for doing all the plugs on all the cables and joining all the wires. And one of the things that was worrying me was that I had literally got some wires crossed, and that's why we were getting this funny signal. So it really was quite worrying. I had nightmares about how I would be discovered, my incompetence would be discovered, and I'd be kicked out of Cambridge without my PhD. I missed out on the Nobel Prize, but I think out of sympathy I've had virtually every other prize that moves, and I think I've had much more fun out of it. Because if you win a Nobel Prize, you go to Stockholm for a week to receive that prize, and it's a fantastic week. I've been there as a guest, out of this world. But at the end of the week it's all over. Nobody ever gives you a prize again because they don't feel they can match the Nobel, and that's it. Whereas if you don't get a Nobel Prize and get carried like I've been carried on this wave of sympathy, then you get lots of prizes, and each year there's a party, and it's far more fun.
So how has she managed to juggle achieving all of this with having children?
It's been very difficult, I must say, combining family responsibilities with work. Partly because of the generation, the age that I am. I'm now in my early 60s, and when I was a young woman, women with children weren't expected to work, they were expected to be at home. So there were no facilities for minding children. And it was difficult. It needed imagination and ingenuity and stamina and energy to get the child minding taken care of and get yourself to work and cope with it all. I worked part-time for many, many years as the best compromise. But I'm fully conscious that my colleagues thought because I was working part-time I wasn't serious about my work, when in fact I was far more serious than they were, and having to work a lot harder to get to work than they did. These days I'm having a ball, I really am. I do quite a lot of lectures to all sorts of bodies, WI, amateur astronomical societies, school teachers, public, what have you. And I very much enjoy putting the subject across to people. It's a great subject to communicate, and so I really do enjoy that. And I do some lectures in the university, and I do a lot of committee work, and I do some research, and it's a good balance. It's great. I think science is a great field, and I would encourage everybody to go into it. There are a lot more women in science now than there used to be, and you often find that, well, in many areas of science, half the students are young women, so it's changing quite fast. Science is important for the country, and science underpins a lot of the comfort in our life, so it has great impact. So yes, I would encourage lots of people to go into science. I think the future looks quite impressive. We need science as a country, as a planet, more and more. We also need thoughtful scientists, people who think a little bit about what they're doing and its consequences and its ethics. But science will continue to underpin our advancement as people and underpin our ever-improving styles of life and health and all those things. It's surprisingly key as a subject. Because I'm one of the first women in the field, I've never had a mentor or a role model for that matter, and I've had very much to make my own way. I hope in that respect it's easier for women today, and I'm keen to support women coming into the field. I find it very enjoyable. I find the subject very stirring. Astrophysics is very fast moving. There's new theories, new data rolling in all the time. So it's immensely lively and forever changing. And the buzz in an astronomy department over coffee in the morning is just amazing, as people are relaying bits of news that they've heard. It's very dynamic, and that keeps you young. There aren't that many senior women in science yet, but the few of us that there are have got to know each other over the years, and we support each other. We keep each other going. We meet up occasionally, not officially, just bump into somebody, and that's how we do it. We network. Another great thing about astronomy is that it's international. You're going abroad to use telescopes, you're working with people from other countries. We've just done a quick count of how many nationalities there are in the department here in Oxford. There's 110 people, and we counted 22 nationalities amongst that 110. International collaboration is very much the rule of the game, and it's an important facet. So if you're going to be an astronomer, you need a passport.
What about any advice for women and their careers in general?
For women who are considering careers in science, or indeed demanding careers anywhere, I think two things are important. First of all, you've got to believe in yourself. You've got to have confidence. And women often don't have as much confidence as the men. So you really do have to work at that, and you have to believe you can succeed and stick at it. And you will succeed. And the other thing I'd say is, if something new comes up, you're asked to do something, have a go. Often we're too cautious and retiring, but if you have a go, give it your best, you'll quite often surprise yourself, and you'll learn more about your own abilities through doing that, as well as doing a good job. So have a go.
And finally, I just had to ask the big question. Is there life out there in space?
I'm often asked if there's life out there in space. Of course, I don't know for sure, but I suspect there probably is, because the universe is a very, very big place. But having said that, I think the chances of making contact with it are about zilch, because the distances are so huge. Radio waves and light waves would take millions of years to travel from them to us, and that's no way to have a conversation.